Hey everybody, it's Darth Digger here again, and I just wanted to make this video because I got a couple of questions for clarifications about the Redstone repeaters, and I wanted to make sure that I made everything perfectly clear. A Redstone repeater, it looks like this, and a Redstone repeater essentially serves three functions in the game. It was originally, I think, made up for one particular purpose, and it has essentially a side effect, although it might have been on purpose, who knows, which allows it to be used for a couple of other purposes. Now, obviously, the engineers in the crowd are going to be able to say that they use it for thousands more things, and you can in the higher functions, but I just want to talk about three basic functions right now. Okay, so the first and really most important, although arguably not the most useful function, is to use essentially as a transformer. The redstone, just like electricity, can only go so far on its own, and then it needs to be helped along the way. And in electricity, we use a transformer to do that. In Minecraft, we use a redstone repeater, and I'll show you what I was talking about again. Like I was saying in the last video, when you turn on a circuit, a switch, it powers whatever it's touching, and the line starts to glow red and sparkle. Now, the further away you get from that switch, the deeper red it goes, and at some point right here it stops sparkling. So that means if I put a sticky piston here, alright, let's do that differently. It's going by the side, so it doesn't know here. So if I put a sticky piston there, it's going to work. But if I go down here, in fact I think definitely here, it's not going to work. Why? Because that bit of line isn't sparkling. Now I think this will work. Yeah, that's the furthest out it'll work. Alright, and that's because that switch can only push the line so far. Now, theoretically, I could put another switch there, but if I turn that on, what it's now going to do is it's going to cause all sorts of problems with itself. It's going to, if I turn this other switch off, watch what happens. That switch that's up there actually powers the line both ways. Okay, and that would have undesirable effects. Alright, and you've got to go out here and turn it on and off independently. It just wouldn't work. So in order to get through that, what they did is they made a redstone repeater. So you go out to, now again, I think, there you go. So you notice the line's not sparkling there, but the line is sparkling there. So the furthest out that I can push this is right there. So if I put it right here, it's not going to turn on. But if I put it here, nope. And actually this is important too. See, I wasn't facing the right way. So because I'm not facing the right way, no current's going through. If I face it this way, no current goes through. If I face it this way, no current goes through. The only way it's going to work is if I face it that way. It turns on, and now it's going to push your current for another 15 or 16 blocks. I keep forgetting the number. I think I got a brain block there. Okay? And it will keep doing that. So, the main and primary reason to use a redstone repeater is if you have a line where you want the switch or the power source to be somewhere very far away from whatever it is you're actioning or your load, whether it's a door, a piston, or what have you. Okay? But as I was saying in the last video, and if we come back here, you'll remember, it has a side effect, and that side effect is that it acts essentially as a capacitor. And what that means is when you put power into this end, it actually stores up that power, and you can watch it move along until it actually gets where it's supposed to go, and it activates whatever it is. And now it's still storing the power. So now I've turned that off, and now it's discharging, just like a capacitor would. And it keeps whatever you had there on for that much more time. And essentially what it's doing is it's delaying the power from getting to wherever it is it's supposed to go. And as I showed you in the last video, we use that to do things like this to make sure that things happen in sync. Okay? So that's the second reason that you would use this. Now, this demonstration that I've got over here is going to show you the third use. So the first use, again, is to extend the length that you can put your redstone out. The second use is to delay or put a timer into something. The third use is really making use of the delay and the capacitor ability of a redstone repeater. Okay? And you'll notice, I'm just going to go up here, what I've got laid out on the ground here is essentially looks like a circuit. Okay? And really what it is it's called a clock. And this particular one is a 3-in-1 clock. Okay? And what that means is you will get one pulse of on power for every a tick of on power for every 3 ticks of off power. And a tick, I don't know, at some point I'll time it and see exactly how much it is, but I think it's either a tenth of a second or a quarter of a second. It's something, very short. And what's going to happen is I'm going to turn this switch here on just very briefly, and what it's going to do is it's going to power this line. Okay, it's going to go up here and it's going to open that door, but that's irrelevant at this point. It's not the point of what we're doing. It's also, at the same time, it's going to come over here and it's going to try to go through this redstone repeater, but it's not going to be able to because this redstone repeater is facing the other way. And that's why what I was telling you before about placing the redstone repeater facing the right direction is critically important. So it's not going to be able to get through there. So instead what it's going to do is it's going to come up and it's going to hit this redstone repeater here. Now I've got this set to 4 ticks right now, which means it's going to delay it to its maximum possible. Quite frankly, the circuit gets a little bit unstable the faster that you make it. So it's going to power this redstone repeater, and this redstone repeater is going to delay it. Now, I'm going to turn the switch off by the time it gets there, so power is off, but this redstone repeater will already be powered. Then, because of the direction it's facing, it's going to send its power down here, and that power is going to go out to this door, and it's going to open that door, but it's also going to split off to this redstone repeater and power that one. Now, this redstone repeater is going to hold the power, again, for 4 ticks, before it sends it on. When it sends it on, by the time it sends the power on, this first redstone repeater has let it go. There's no more power in that, so this door is going to close while this redstone repeater is powering. It's going to send the power on to this redstone repeater, and they're just going to keep passing the power around from repeater to repeater to repeater. And that's why it's called a clock, because the power keeps getting passed around, and you can actually create a stable, what's sometimes referred to as an oscillating circuit, or a something that you are going to be able to set particular movements to. Not random, but actually timed movements. Okay? So, I'll turn this on. So notice I turned it on and off quickly. Now, you can watch as the power, get up here again, goes around from redstone repeater to redstone repeater in a clockwise motion. That's because that's the way I set up the redstone repeaters. But, so you can see what I was telling you a second ago of how exactly it passes the power from one to another. And you'll notice when it's passing it from one to the next, it's also powering the line that is attached to the door. And aside from a little bit of video lag here, what you can see is that the doors are now opening in a very specific pattern. There's some video lag which makes it look like the doors are half and half, but they're not. The doors are opening just the same as this one is. There you go. It shows it better there. Okay, and that's what's meant by a clock. So, and unfortunately, this is essentially an infinite loop. So the only way that I've got to turn this off right now is to take out a piece of the redstone in the middle there. So, just to recap, 3 really main functions of a redstone repeater. The first is to extend your power. The second is to time or delay either the starting or the stopping of a circuit. And that could be so that when you step on a pressure plate, you've got enough time to run up and get through the door before it actually turns off. Or the third is to the delay you could also use to time the opening of a door, such as these doors over there. And then the third one, because of that delay, it allows you to set up a clock circuit. And again, the redstone repeaters will act as a backflow protector, ensuring that your current will always go in the direction that you want it to go. Now, I just want to say thank you for asking the questions, and hopefully this helped make it a little bit more clear. And if you've got any more questions at all,